Okay, so we'll take a look at this circuit, and the first thing we say is, okay, it does not look like any of the circuits I already know. So it does not look like any of the circuits I already know. I have to find V out. This time it's not saying find an expression for the gain, it's just saying find V out. So so we are not going to find the gain individually on this one. We're just finding V out. So the first thing I'm going to do, because I don't like current sources, is I'm going to do a source transformation to change this to a voltage source. So this will be plus minus 2 milli times 2 kilo is 4, so 4 volts times a 2 kilo ohm resistor, and then a 6 kilo ohm resistor, and a 4 kilo ohm resistor, and a 6 kilo ohm resistor, and this is 5 volts. Okay, so I know, and I always write these things down, I know that IP equals IN equals 0, and VP equals VN. And I'm always excited when I see something like this. I've got my 5 volt voltage source in my non-inverting input, and I can say that, hey, that's got to be VP, so that's got to be VN, so hey, I've got that all figured out. So I know VP equals VN equals 5 volts. So I know right away that I've got, this is 5 volts here and 5 volts here. Okay, then if I look at, I called this voltage right there V1. And no, yes, I did. I know that this current right here, this is IN, that is 0. But my voltage right here, that's VN. So my current going from here to here would be V1 minus VN over 6K. All of that current then has to continue through this other 6 kilo ohm resistor. This voltage right here is V out, and so that has to be the same current, so that has to be VN minus V out over 6K. So those two currents have to be the same. I know VN is 5, so V1 minus 5 over 6K equals 5 minus V out over 6K, or multiply by 6K, V1 minus 5 equals 5 minus V out, or V1 plus V out equals 10. Great, so I've got some information right there. And then I can also do a little bit of KVL at V1. Yeah, at V1. So I'm going to sum up, so kind of like nodal analysis, I'm going to sum up all the currents at V1 and set them equal to 0. So V1 minus 4 over 2K plus V1 minus Vn, which is 5, over 6K, plus V1 minus V out over 4K has to equal 0. Now if I multiply this equation through by 12K, then I get 6V1 minus 24 plus 2V1 minus 10 plus 3V1 minus 3V out equals 0, or 11V1 minus 3V out equals 34. And then I think I did, let's do V out. This is not how I did it before, so that's a mistake. V out is 10 minus V1, so 11 minus V1 minus 3 times 10 minus V1 equals 34. 11 minus V1 minus 30 plus 3V1 equals 34. 2V1 64 minus 11, 53, that's not right. What's V out equal? Oh, that might be right. Okay, so V1 is 53 over 2. V out equals 10 minus 53 over 2. Which is not the right answer. Okay. Everything is right up until like the very last step. Someone has the answer, what I did wrong?
In that step where you have 11V1 minus 3V0 is equal to 34, the step
Yep.
below is where I think you messed up. You have like 11 minus V1.
Oh, why did I do that? That doesn't make any sense, does it? Thank you. Thank you. So 11, yeah, I just like threw a minus V1 in there for no reason. So, okay, I'm not doing algebra. I mean, the correct answer is that V out is about 5.4, because I can't do math. 5.4 volts. Everything up to here is correct, and y'all can solve for V out and find it. So, yeah.
How did you know VN was 5?
Because VP was 5, and it's an ideal op amp. VP equals VN. Yep. So if y'all want to go ahead and verify that V out is 5.4, because y'all can, I'm sure that all of y'all can do algebra and arithmetic. I just have that disability, so I can't do that. Although they don't give me that as a accommodation. It's like, yeah, I don't have to do the math on my tests, so they don't let me do that. Any questions? Okay, I'm going to stop this, and I do have a little bit of time for a Thevenin's theorem question. So I'm going to stop this and save it. Nick, if you want to stay on for Thevenin, you can, and if you don't, that's also fine. Wait, I didn't mean to stop the share.